Alright, welcome back. So it's time for part 4 of machine learning for network and cloud engineers. So if the program will load, that will allow me to continue. It seems not to be doing that, so I'm going to close it and then open it again. Alright, and then I'll go back to the book here by double clicking on it and continue. One concept I want to emphasize at this stage early in the book is that while the algorithms that comprise machine learning may seem very sophisticated, and many indeed are, ML is basically about brute force. Some people will argue that the reason for solving a problem with ML is that you have not found a more elegant way to do it. ML is about throwing data and computational power to solve a problem that may be too complex to solve in a more analytical way. There is a school of thought that ML should be the last resort only, while a growing opinion considers we should start applying an ML first approach to solve any problem. I do not think there is a right or wrong answer to it. Ultimately, the availability of more computing, memory, and storage at a lower cost are factors we cannot ignore and will directly influence our approach to solving problems. There could be a case of a particular problem for which we could analytically come up with a solution, but it may take time from a domain expert, which is definitely a scarce and potentially expensive resource. However, what if we have plenty of computing available, for example, in the cloud? And we can solve the problem faster with data and machine learning. I am not going to say which is the right way, but we need to be open to exploring all options given the scarcity or availability of the resources. And I will say, when he says we, he means you and me, as he described earlier in the book. But this is not true of me. I actually don't have plenty of computing available, not even in the cloud, because I have to pay for it. And I unless I'm getting a cash flow of my payments, I can't afford to spend millions of dollars on cloud computing. I can't afford to spend $5 on cloud computing. An unmanaged, untracked, unbudgeted for expense is something I can't afford, especially one that doesn't have a cash flow return. So it presumes a lot to use that word we, which means you and me, the author and the reader, to say that the person reading this book has plenty of computing available. That, in my experience, is absolutely not true. I think for most people reading this, unless you're a tried and true entrepreneur ready to invest millions in the cloud on compute, that is not true for you either. So I think the obvious answer is that the right way is, in fact, to solve problems in a more analytical way and to use machine learning as a last resort only, and to do it in a way where you can actually afford the cloud computing services, and hopefully where you can create a cash flow out of them, where whatever you're building you can sell for more money than it took for you to make it. And in that case, you might have some upfront costs that you'd have to cover. So like if you're selling it, you can maybe ask for upfront costs, or you can get funding, a grant or something, or a loan or something to cover those upfront costs. But I would say I'm not going to say which is the right way, but we need to be open to exploring all options given the scarcity or availability of all resources. That's definitely true, but I will say the right way when it comes to being responsible as a, you know, as a person without unlimited resources would be to spend carefully in the cloud. Key takeaway: using brute force should not be perceived negatively. It is about leveraging the available resources in the most optimal way. What is specific to networking? And I have to take a break. I'll be back. All right, I'm back. Still probably got like a good 5 minutes. 10-minute video in the morning is pretty good. Something that you may likely wonder is if there is anything unique or specific in networking compared to other fields or industries that make the applicability of AI/ML unique or different. From a mathematical point of view, the algorithms and problems in networking are very much the same as in other fields or industries. The data generated by an IP network, a data center fabric, or a Kubernetes cluster is nothing particularly unique compared to data generated in other industries. The types of problems to address are pretty much the same, and the types and choices of algorithms are not different. This is actually an advantage for networking and cloud fields. The fact that we have started to adopt AI/ML techniques late allows us to leverage innovation already in other fields, and we will simply adopt them. I am not saying that eventually there could not be something relatively unique to our field, but it would be an exception. I mean, honestly, I would say my opinion about that is like there's so many like unique like algorithms and like you know things going on technologically in networking. I think there could be something unique to the field, because I feel like the field is unique. Scale is definitely something very relevant in networking. Making real-time decisions about the advertisement that each Facebook user's feed needs to show next for 1 billion users seems like a relevant scaling challenge as well. I would say the need for scale is also common in other fields. Similarly, the need to have real-time responses in a critical environment is a crucial factor in network infrastructures. But so do the airplane engines decision processes that depend on algorithms fed by sensor data. What will be presented to you throughout the remainder of the book are completely standard AI/ML techniques and how they can be used to solve networking specific problems. Furthermore, this is the key to how common knowledge learned in other fields such as natural language processing, time series processing, and image processing, shopping recommendations, etc., can be applied almost as is to networking with success. Commercial implementations may likely be variations of the following or similar techniques. The inference path is the equivalent to the data plane where real-time data needs to be processed. You may frequently find optimized implementations of the inference path to achieve the performance, scale, or latency required for a particular use case. Will AI/ML replace people? I know this is a controversial topic, but I wanted to give my view. There is a particular fear that AI will result in fewer jobs. The reality, though, is that AI does not replace jobs. And the other reality is, do you want your job replaced or not? Some people do. It replaces tasks. Should a network engineer or network operations engineer be afraid of AI? I do not think so. A network or cloud engineer should be afraid of internal and external competitors. Suppose you work at a service or cloud provider and one of your competitors implements techniques that allow them to provide better SLAs, increase customer satisfaction, and be more cost effective. In that case, it is not their jobs which are at risk, but yours. No individual. So I kind of didn't take away from that. No individual. I think the takeaway from that is, although it's really not that big of a worry, the worry is that your skill set rapidly becomes out of date, so you do have to learn about this stuff and not be left behind, which is what I'm doing. So let's continue. No individual or team is usually punished by doing their job better. It is more the contrary. It is those that miss the opportunity to improve that will struggle. This is true at individual, team, and company levels. AI/ML is not a threat. It is an opportunity. It is undeniable that the many benefits it can provide, and you will see them very practically applied in many use cases in this book. Those who, of fear, decide not to take advantage of it or not to learn about it are the ones that may be more at risk because they will be at a competitive disadvantage. I concur with Daniel Lacalle, Spanish economist, when he says, "I am not worried about artificial intelligence. I am terrified about human stupidity." That's funny. And I don't think I have to add, every person in the world to my LinkedIn. So this person's an economist, not a technologist, so I'm not going to add them. So I'll advance the bookmark and see how much I can do in the remaining. Oh yeah, I'll finish this out. AI/ML is not your enemy. It is an ally for you to do things better and faster and do things that were not even possible before. Learning AI/ML and applying it where relevant in your network or cloud operation environment will make you a better professional, and your team will deliver better outcomes. Key takeaway: AI replaces tasks, not people. It is a great opportunity to do things better and be more competitive. AI will not replace you, but someone using AI may. And more importantly, if you refuse to adopt it, you ignore it, you've never used ChatGPT, you don't even know what that is, and you're struggling, that might be why. Introduction to AI/ML concepts. All right, so that's it for this video. I'm out of time. It's just a short one this morning. Morning videos can be shorter. So get rid of these old bookmarks, and when I come back, yeah, so that's it. Thanks for watching. Stay tuned for the next one.